Welcome to Through the Corporate Glass, a podcast that explores career choices. We dive into the latest trends in tech careers, demystify industry roles, spotlight startups, and even explore unconventional paths outside the industry. Join us for authentic conversations that will challenge your assumptions and inspire you to think differently. Welcome to another episode of Through the Corporate Glass. In this episode, we'll learn about the role of a decision scientist and how it's related to data science. We'll also contrast data science research with roles in the industry to point out both strengths of each as well as differences between them. We'll unravel the skills required to be successful, the opportunities, and then also the challenges as we chat with Anand Ramanathan, a decision scientist at Meta. Anand has a fascinating background with a PhD in physics from the University of Maryland and more than a decade of experience as a physicist at both NIST and NASA before embarking on a career as a data scientist. I know Anand from my years at high school at Vidyaniketan, and I remember him to be a math wizard, of course, with a very calm temperament. I know from our background that it's not a very typical decision to pursue physics when you're the school topper, right? There was this implicit thing that you got to get into engineering or you got to get into medicine. So I'm very curious about what made you pursue physics.
Yeah, great question. So actually growing up, you're very familiar in the 90s, software engineering was the big thing, the new thing where suddenly you're getting this lots of jobs and opportunities coming to India at that point. And I was very excited. I also liked programming, so that helped. However, in my 12th standard, I suddenly started taking an interest in physics. And I really like in particular the field of optics and light and other things. And it got me very excited. And at that point, I felt, hey, this is a great thing to do. And my parents were relaxed about it. So it also helped that I was going to study in IIT. So people know, okay, if you're in IIT, you're probably going to be okay. Your career's going to be fine. But interestingly, I got a letter from my grandfather, a real physical letter. He felt, hey, I have this grandkid that's academically good. Why is he studying a field that's 200 years old or older when there's so many new opportunities? And it's very interesting in my reply. I wrote that I addressed his concern and say, don't worry, I got this. And maybe after I graduate, I might take up a software job. It's always an option. And funnily enough, speaking now like 20, 25 years later, maybe I have what I have is a software job in some regards, in that I'm working for a big tech company. But I think my journey has been a lot more interesting by taking up physics.
No, absolutely. Thanks for sharing that because I think a lot of us would get those letters, and then how you react to it actually decides the course of your action. So let's go into your journey. I'm curious. So you finished physics at IIT, and then how did you end up at NASA? It's everybody's dream job, right?
So I'll be very honest. When I went into physics, NASA was not on my dream. Like I met a lot of people for whom going to NASA was their dream from when they were a kid. I wasn't one of those people, but it just ended up that I went there. So let me back up for a second. So as I said, I like optics. I really took additional courses while at IIT on optics. I did my PhD on atomic physics, where you control atoms with light. It was very satisfying, and I really enjoyed it. And I think maybe I filled my passion, and I had my fill. And then in my third or fourth year of my PhD, I was like, okay, I think I want to do something different. I wanted to be a little bit more applied. And at that point, I was looking at industry. And of course, tech companies were attractive. However, at that point, my wife was just starting to do her PhD at Johns Hopkins. And so I limited my job search around there. And also, I didn't know how industry was at the time. So what I ended up doing was I spoke to a team at NASA, and I liked their work also on lasers, although the invisible kind, the one you can't see. And I liked their work. It was exciting enough. And so then I wrote a 15-page proposal. It was evaluated. And And then I got into NASA.
That's an amazing story for multiple reasons. You said it wasn't your dream, and then you ended up getting into NASA. And then I think you also referenced the famous two-body problem in academia, where you have to figure out how your spouse and you can end up in the same location. So how was it at NASA?
Yeah.
Did it live
So,
up to the hype that the rest of us have around it?
uh, yes and no. So first, it was really nice to be part of NASA. They have a really great mission about putting things in space. They do lots of cool things. I got to speak to a lot of scientists who are really passionate about what they do, and you had the time to actually ask them what they do, and they would explain it to you. So in that sense, it was really nice. That being said, NASA is not where you're always doing cool things. There are the more mundane parts of your job. There's all these regular things to do, like clean up the data, write a report, and all of these things. And so I think in the end of the day, if you take sort of the NASA part, it's not too different from other roles I've been a part of. So, like they say that doing great things is 90% perspiration and
Perspiration.
10% inspiration. And it's pretty much the same there too.
Yeah. So can you tell us what you did at NASA, Anand? You
Yeah.
did reference that you moved out of theoretical physics into something more applied, right?
Yeah, so not theoretical, I would say fundamental physics. I was an experimentalist, so I used to work in a
Okay,
lab.
got
And
it.
so in physics, there's really a sharp line between people that work in a lab and people that don't. And they always joke that the people that work in the lab joke that people who don't have no clue how to operate an oscilloscope or something like that. And sometimes
Okay.
it's true, but that's just a joke. So being an experimentalist, I always prided myself being an experimentalist. And I think what I really liked was getting feedback, trying something and getting the feedback. Whereas a lot of theoretical physics, people don't actually try things in the real world. They're just solving equations or building theories that explain certain things. So I feel they miss out on the fun of this unknown where you don't know. You say, I have this great idea. Let me try it and let me see what my instrument tells me. And oftentimes it tells you something completely different. And that's just part of it. And then you learn how you learn from that, you make it better. And eventually, after all the perspiration, you get to something along the lines of what you wanted or what you were expecting. So
Right,
that's a cool
right.
part of experimental physics. Moving to NASA, so I think my experimental physics was absolutely key in making that move. So I joined a lab that operated laser instruments on aircraft. So they would put this instrument on an aircraft and shoot a laser beam down, and the laser beam would hit the ground. Some light would come back, and based on that, they were able to measure how much carbon dioxide is in the atmosphere, which I thought was extremely cool. And I think the transferable skills I brought in was a sort of general physics background where you know how to handle the math, understand the equations, understand the physics of it, but also the instrumentation skill where you can work with lasers, you understand how instruments work, you understand things you need to do like calibration and other things. So the sort of skill set was what got me in.
That's interesting. And so, how does the measurement aspect relate with data science? Or is that where you got interested in data science?
Yes, yes. So I think that's a very good question. So the measurement aspect of it is like, I think I was actually for the first time dealing with a lot of data. So basically, data that, when I say a lot, I say data that can all not fit in memory at one time.
Yeah.
And so you have to be a lot more systematic about it. You have to understand how do I distill the information I want from this data so that I can actually work with it. Or you got to work in parts while you distill it down so that you figure out, okay, what's the best way to distill it down? And then you often have to join data from different instruments. And like, for instance, the aircraft had data about position and what they call attitude, how the aircraft is tilting. And then based on that, I would have to join that with the measurement of CO2 to know, hey, where in the atmosphere were we measuring? Were we above a power plant or not? So this kind of joining of data I think, was a great segue to the later part of my career in data science.
Oh, that's really interesting. And would you say, taking a little bit of a tangent over here, right? Just so that we understand the data science landscape a little better. There are a bunch of different roles around data science broadly. Could you give us a little bit of an insight into those roles?
Yes, yes. So there are actually lots of roles, and to be honest, found them confusing. And also keep in mind that different companies treat them differently.
Right.
So I'll list a few out. So the first is what they call data analysts, or sometimes product analysts, or at Amazon they're called BI engineers. And these folks are less specialized. They kind of can do a little bit of data engineering, a little bit of what's called analytics, and I think their focus is to, hey, get the data ready for other people to use, like dashboard building and or pipeline building and other things. Then there are data engineers, which Harini explained really well, so I don't have to go back into it. And those people are really much more in the data. They understand data pipelines. They even sort of have a systems view of data pipelines. And a lot of this is not just for analysis, but also for the product or whatever that the app or website does. Then there are the business analysts, and here it's a bit like the word says, it's a little bit more on the business side. And so these people tend to focus on what matters to the business. And oftentimes they're not expected to be experts at handling large amounts of data, though that might be changing. But then I think even for those roles, it's like you like the front-facing part of the data. You like to be the one presenting. You like to be the one figuring out what needs to be done, a little bit more into the strategy and other things. Then there's one more, the financial analyst or quant. And this is I'm not too familiar with. These are people that work on Wall Street. They have finance. There's math around stock markets. It's actually very different from anything I've worked on. But it's just good to be aware that's also an option. And of course, we'll talk about data science later, but in general, data science is basically working with data in a scientifically rigorous way and using techniques like machine learning.
Awesome. Thanks for that landscape. And I absolutely love it when somebody references a previous episode of our podcast. So thanks for calling out Harini's episode.
Yeah, sure. It was great. It was a really good episode.
Yeah, I'm sure Harini will listen to this one and respond to you. But so that's very interesting what you said, right? So broadly, would you map the measurement piece and the data analysis aspect to a data analyst role? Would that be a
No,
broad? I know you did more than that in.
no, yes. And that's another, actually, you raise a very good point. So when you're working in smaller teams, like I was at NASA, you actually take on multiple roles. So in a sense, I was doing sort of the data engineering to some extent. I was also doing the data science, which is analyzing the data and then also presenting it in a scientifically rigorous way. So I was wearing multiple hats when doing that. And towards the end, I was also a little bit more front facing, where I would say, hey, we should probably do this or do that based on what I've learned. So
Yeah.
And that's the good thing of whether you work either in academia in some parts, or whether you work in a small company, you get to actually play a much broader role than if you worked in a large company where everything is much more specialized.
Yeah, actually, that's a great point. It resonates a lot with me because I worked at a super early stage startup. You get exposed to like a lot of different things, and to the point that sometimes you don't know the demarcation between many of these roles. And over and above the data science aspects, I'm sure you had a physics aspect to it as well in NASA, right?
Yes. So we were measuring light going through the atmosphere. You had to understand how it's absorbed. You had to be able to read the equations. And even though I wasn't an expert, at least have a functional knowledge of knowing what question you're asking, how does it generally work, and how will this scale with, like, say, hey, if you put this in space, how would it do if we flew lower, higher, and all. There's a lot of physics that went into it.
And you made a choice to move out of NASA at some point and go deeper in the data science area. So,
Yes.
what motivated your choice to one, give up physics and then double down more on data science, right?
Yes. So definitely when I left NASA, that was definitely giving up physics. And a lot of my family were like, oh, no, you were the only one. And now you're no longer. But for me, I think it was more a sort of a reality. So my project at NASA was ending, or I foresaw that the funding would not be extended. And that's pretty normal at NASA. It feels like it wasn't a question of us not doing good work. It was more that there are always so many ideas out there, and only some of them can go to space. And if you don't have any plan to go to space, NASA will not fund you. And we were at the point where our instrument was working well, but laser instruments in space had turned out to be very expensive. There was a satellite that went called ISAT-2 that the budget ended up going over $1 billion when it should have been more like 300 million. So after that, it was pretty clear that they're not going to send a more experimental laser instrument to space for a while. And so that percolates down, and eventually our funding got cut. But before that, I saw this coming, and also I think there's also a general truth to this, is that you can be in a great project, but even in industry, but things end, projects end, they move on, priorities change. So you can love something, but don't get too attached, or don't expect to be
Yeah.
spending all your life on it. Or so that happened at NASA. So I had to either pick up a different project which I wasn't too keen. And I think at the same time, data science was really expanding in industry. And I was like, okay, coming from NASA where funding was so tight, I was like, I want all this funding for myself. At NASA, my salary was paid out of a grant. And so you're employed only as long as the grant keeps coming in. And I could see that this thing was going to end at some point, and I didn't want to pivot to a different grant or a different project. So I think the logical choice was to take advantage of industry and move there.
I think that makes a lot of sense. I've been in those situations as well, where it's a great idea, it's a great project. You're forced to be practical many times to make the right decision. You moved into data science, and I think your immediate next step was essentially getting into Capital One. Now, it's an interesting choice for multiple reasons. One is, of course, you clarified why industry made sense from the funding aspect of it. How did you find the transition from NASA to industry?
So the transition was rough, to put it mildly. And that was simply because I didn't know what I was getting into. And not in a bad way. It wasn't like it's a toxic team. It was nothing of that sort. People
Yeah.
were nice. People were nice to me. But what I didn't know when joining was that, so I was joining Capital One. So I obviously knew people are hiring me. So I assumed that my team would at least have a plan for me in terms of the data and so on.
Mm.
But it turns out that I was within a marketing team, and our leadership was marketing. And sometimes it's also where the leadership decides which question is worth asking. So sometimes I would see things not being spent well, but they'd focus on something completely different and say, hey, you need to do that. Tell me if this creative is better than that creative. Whereas I'm sitting here and saying, hey, I don't think your marketing is working at all. And that's not a good question to ask. So on the plus side, I learned a lot about how marketers think, on how do you talk to them, how can you explain things to them, and what do they like to see, which is always a good skill. But it was hard because I learned the lesson that, hey, you can only do what your leadership wants you to do in some sense, especially with the culture so strong as marketing is. And the good thing was also I learned a lot of technical knowledge. Oftentimes, people on the data science side don't learn as much of the technical details of how things happen. So that was super valuable to learn, which for me, whereas for marketers, it was probably just what they needed to function. And that helped me, and has helped me ever since. But coming back to your original question, it was rough, and it took a lot of adjusting. And I think at the same time, I think when you have tough times, I wouldn't recommend it, but you actually learn a lot. You actually become more resilient. You actually you try a lot of things. Sometimes they don't work at that point, but after that, those times have passed, when you try them out at other times, suddenly you realize, wow, I'm really good at this. So had a couple of experiences where, I would spend all this effort to try to convince someone to do something, but then it wouldn't work. But then later, when I would put that much effort, suddenly I sound very convincing in a different context. So I would say it was tough, but it was beneficial, maybe a blessing in disguise in some ways.
Wow. So this sounds more like trial by fire. It's
Trial by
like,
fire. Yes.
so at least my read of this, and then of course, I'm sure you'll have a deeper perspective on this, but it sounds like a compromise between autonomy and funding, right? If you do research versus industry, is that a fair?
That's very well put. So I had basically traded off and research, and there too, there's more autonomy, but I think I was also in better alignment with my PI, because everyone's a scientist there. So we were all in good alignment as to what needed to be done. And then here I'll end up in a situation where you have less autonomy, and you're not in alignment with what your leadership wants. And in some sense, they say, hey, I'm paying this guy to do this. Why is he going and doing Y? Hey, this is priority. We have all these things to do. Why is he going off and doing something else? But it got sorted. So Capital One was nice enough that after a few months, I got put in a different team, and that was a much better fit. So, people were still listen to me, and at least they're like, okay, you know what, you'd be happier there, and you can do better work, probably do better work there. So I got reorged, which was a good thing.
So you moved on to marketing analytics at Audible from here.
Yeah.
How is this different from
Yeah.
the role? And yeah.
So just for the benefit of listeners, in marketing, basically companies pay a lot of money to put their ads out there. And I think the question that everyone has is, do these ads really work? You see these annoying ads, you hate them, and you're like, this doesn't even work. And
Yeah.
I think the short answer is sometimes it works. I was doing that at Capital One, and that was a natural next step would be to do something similar at Audible. But right off the bat, Audible, of course, I had been in industry. I knew what questions to ask. So one of the first questions I asked is, do you report into marketing? And my manager then, or my would-be manager said, no, we don't. We report into finance. We're completely independent, and you can speak your mind. I was really happy to hear that. And so right off the bat, I made sure I was in a better place. And the good thing was my role at Audible turned in from more analytics to more data science. And also Audible made this huge change, which I really liked, was where initially they focused on the data science, focused on making these models measuring based on observational data. The effort you put into the models, they're not as good as they should be. And they shifted from doing that, like there's something called a media mix model and so on. And they moved to doing experimentation, where they would turn off marketing in certain places, and you look at, hey, did we see a drop in the number of signups we had in those regions? And like I said, experimentation is something I love, and it was a lot of fun. Like there was the thing of learning something new and making a prediction ahead of time as how much of a change do we expect, and does it match that? And then making sure you're designing your test right, and also analyzing the data and making sure that the results are make sense, are understandable, and you can explain it to a marketer audience.
Wow, I actually love that. I think now there's I don't know if I should still label it up and coming, but essentially there's an area called growth marketing where they do this for every product feature as well,
Oh yeah,
where
absolutely.
you,
Absolutely.
right, like you roll it out to smaller segments, you look at the
Yes, yes.
traction and yeah, yeah.
Absolutely. So that's the thing. So almost any big tech company or even the smaller ones, when they roll out a new product feature, they always what's called A/B testing it, where they'll turn it
Yeah.
on for some of the users and then keep it off for the others and make sure it's having the impact they want and no other negative impacts. And actually, that's also one more thing to note is when you're doing it within your ecosystem, like say when you're on Audible and doing something on your app, you can randomize people at the individual level, which is fine. But it's when you're advertising outside, that's when you can't randomize at the individual level, because you can't tell other, like say Google, or you can't tell Facebook, hey, turn off for these people and tell
Oh,
us
that's
who
true.
signed up or so. So
Yeah,
you have to
yeah.
do it at a region level because you can't do it at a user level.
Right. Yeah, that's certainly super interesting. So now coming to decision science, which is your current role at Meta, right? Could you first explain what the role entails? And the first time I saw it, it wasn't clear to me what a decision scientist actually does.
Um, yeah, and I think that's a great question. Traditionally, data science tends to means, hey, build models to help me understand marketing or whatever else. And analytics is more like, give me insights about what our marketing doing. But I think the decision scientist takes it a step further and says, okay, you can do whatever you want to do. You can build a model, you can make a measurement, but whatever you need to do, it needs to justify a decision we make. And what I like about this is you are given a lot more, you're given a seat at the table when decisions are being made, but it also gives you the responsibility that, hey, whatever you do, it has to be towards making a better decision. And that is a really good way of making you focus on what's important versus something that maybe is interesting, but not so important.
So you're focused on the consequences.
Yeah.
Okay.
And And the decision in marketing is not just about, hey, where to spend or which channel to spend or where or how to spend, but it's also about, hey, should we test this or not? How do we test this? What do we expect to learn from the test? And I think, and having been at the company for a few months, they also get into, hey, what are some sentiments that actually matter? Does like there are standard things like consideration and loyalty or brand love. There are all these feelings we have, and here we try to distill it out into, hey, how do we measure this? Usually by surveys, and how do we track changes in this depending on how marketing went?
Got it. Got it. So would you say it encompasses a few different roles, like the data science aspect, as well as making a decision on when to apply analytics?
Yes, exactly. It's not just about doing the work, it's also about defining the work, being aware of what decisions are coming, trying to figure out, okay, for that particular decision, I see, it's an important one. What can we do now so that we make a better decision later? Do we test something? Do we do a small test to see if one thing works better than the other? Do we need a large test? And or do we just look at some past test and make the recommendation based on it? Or do we say, hey, you know what, this particular thing is very hard to actually measure, and we will use something else. Uh, so try to give the best answer you can give.
Got it. What would you think are the main skill sets required to be successful in this role?
Yeah. Yeah, I think for this role, this would be a little heavy on the working with people, working with stakeholders. So
Right.
to be able to really understand what their needs are, understanding what they want, and being able to explain things in terms of that. And you work with different kinds of stakeholders. Some are more technically savvy. In that case, sometimes it's easier. And then some are less technically savvy. In that case, you need to put a little bit of extra effort trying to explain your thinking so that they have some kind of trust in what you're doing. So that's one piece of it. Then, of course, there's the standard data science stuff. You need to be good at your coding. You need to be good. You need to, be able to analyze data and really be good at spotting something that's making sure it makes sense. Like really not just going by the first thing you see, but really pressure testing it and making sure, okay, I've tested everything. It makes sense. This result is real. You can lose a lot of credibility if you say something incorrect or if you don't call out a risk. So you want to make sure you're really thorough about it.
Got it. That makes sense. You mentioned programming. Is there a particular language?
Yeah, and this is pretty much a standard for all data science. It's Python and
Python.
SQL usually. Yeah, and Python. There's just a huge library of things out there that you're much better off programming Python than any other language that you might be familiar with. And SQL has again now become the standard, especially when you want to take large amounts of data into a smaller set or extract data or do anything. SQL is sort of the go-to language for a lot of this.
Got it.
In general, if for people that are interested in, say, data science and decision science, I think the first thing is you really have to be curious, and you really have to want to have questions answered from the data. And of course, you need basic math, programming experience. You really cannot do your job without those. And for people that come from academia, I would recommend industry where you're actually working with real data about real people. And hopefully that should get you excited enough to know to be a data scientist.
I usually ask this, and this may not be relevant in the data science world, but is there an open source project or something that people can play around with?
There's a competition Kaggle, which I highly recommend for those that want to break into industry. At least doing one Kaggle competition is super important. There's a huge community out there that are interested in data and data science.
Awesome. Perfect. We'll put that in our show notes. I know a lot of learning in a field gets shaped by some of the books that you end up reading. Do you have any book recommendations?
Yeah, I do. So the one book that really changed how I think is Daniel Kahneman's Thinking Fast and Slow. We'll put it in the show notes.
Yeah. Yeah.
And it like, to give an example, we oftentimes say you have a decision to make, and again, this comes back to decision science, and you want to say you're not sure if it's going to rain or not, and say there's a concert you want to go, you're not sure it's going to rain or not, should you sell your ticket or not? We're often afraid of making the wrong decision and regretting it later. But the truth is, at that point in time, we actually don't know. And I think we as humans don't necessarily are not good at realizing that, and we'll often do something and regret it later. And I think this has changed me a lot in really focusing on, hey, what do we know now? This is all we know. We can be wrong, making a decision and then moving on. And then later, if things don't go one way, you say, hey, I did that at that point. I couldn't have known better. If I'd known, I would have changed it. So that's one example of Daniel Kahneman. There's a lot of great stuff in the book. Like, for instance, say you want to get an estimate about, hey, is this kid who's starting a company, is he going to be the next Steve Jobs or something? And it's a very hard question to ask because you're like, what's your reference? And there's actually a way of answering it. And the way of answering it is you say, okay, what are the odds of someone making it that big? And it's pretty small. Let's just say it's maybe one in like 10 million for someone like Steve Jobs, or maybe 100 million, 1 in 100 million. And say this kid is like 100 times better than the average person, that's great. So 100 million, and then you can make it 100, it's still a 1 in 1 million. So it's still pretty small. So those sort of things, there are a lot of great things in the book to help you make decisions and help you understand how you think and make better decisions in many ways, in your personal life and professional life.
Yeah, absolutely agree about that.
And then there's one more book, which is a follow-up, which is called Noise by Oliver Siboni. And that actually is also a really great book. And I think you should probably read that after you read Thinking and Fast and Slow. So it just talks about how when we have human judgment, there's a lot of noise. The book argues that having noise where different people making a decision will lead to different outcomes is simply not a good thing for most organizations. And this is separate from creativity, where you want different ideas. This is where you want things to be the same. And here's where I also think, in my role as a decision scientist, one thing I ask myself is, hey, if someone else was in my shoes, would they be saying the same thing? And if the answer is no, you then might want to say, there are some people who look at it this way, but I look at it this way, and explain a bit more. But you really want to have a standard where no matter who's looking at the data or who's making a decision, it tries to be as consistent as possible. And that's a good thing in general for companies, even when you don't know what the truth is. Like, sometimes there's a truth, but oftentimes it's judgment. And what he argues is that try to get everyone saying the same thing, regardless of person, makes for better judgment.
Wow, that actually sounds fascinating and very relevant. I haven't read Noise, so definitely going on my reading list now.
Yeah.
And, so, Anand, how does decision science relate to decision making in general?
Yeah, great question. So first, I think there's a misconception that decision making is only for managers and leaders and CEOs. But often, all of us working in jobs, we make a lot of small decisions every day. For instance, you notice a bug in something you're looking at. The question is, do you ignore it? Do you just fix it? Or do you schedule a fix later, or just tell someone else? So this is a small decision. Other times, and I'm sure this has happened for you too, a promising idea comes up in a meeting. And then the question is, hey, is it worth doing sooner? Can we do a quick trial? Should we do this instead of something else? And these are the decisions we all make that are the reason why we're hired to do the jobs that we do. I think we often get graded just based on how much work we got done. But actually, part of our job is making the right decisions for all these things and handling them in a nice way and doing the best for the company.
Right.
Yeah, and then there's also a long history of companies trying to make better decisions. Like, over the course of the 20th century, we've had support functions like finance, accounting, HR, legal, and information security. And what these functions do is bring some transparency to the decision-making process related to these functions, and they stop some really bad decisions that a company could make. Then environmental, labor, and other regulation also help make better decisions, like don't hire kids for the job. And they stop companies from doing things like polluting the air or exploiting workers and so on. It could be in an automated way, like, say, on Netflix, when you get a recommendation, the algorithm's making a decision to show you one title versus the other based on your history. So I think the term decision scientist is actually a great reminder also of all these things And it really ties into decision making in companies and tries to make companies make better decisions.
Yeah, that's actually phenomenal. So that gives a lot of intuition around the role. Another question I had for you is, of course, this is the age of generative AI. How has this kind of creeped into your role, or
Yeah,
how is it impacting it?
that's a great question. This ties into how the role has changed. I think in the last 1 year, like Gen AI has come about, and specifically for data science, like it's able to help you write code. You have things like Copilot, other tools. A lot of companies have internal tools. And I think the key thing is to actually work with these tools. We shouldn't think of these tools as taking our jobs. We should think of these tools as helping you do your job more quickly. And again, it comes down to also standardization of code and so on, so that you can leverage these tools and do better. So I think from a coding perspective, Gen AI is here to stay. It's going to change the role. And all of us that have lived in a world pre-Gen AI have to be better at doing our jobs by using these tools. More generally, I think Gen AI also does things like lets you, like you have someone's code in a different language. I'm sure it happens a lot more in software
Yeah,
engineering, but
right.
even in data science, it happens where you have someone's code in a different language. Like one of my colleagues had written something in R, and I haven't learned R, but I could figure out something, but I could always ask the Gen AI to explain this in more detail as to what it's doing and what's the library it's calling. And it does a fairly good job. You can even ask it to translate. Sometimes it's okay, sometimes not. So I think using Gen AI and rethinking our jobs in terms of how can we be better at what we do with Gen AI is, I think, a key component. And then finally, I think it's also useful in terms of writing feedback. I find that writing feedback is where it really polishes up what you're trying to say, provided you give it the right prompts, or say writing a recommendation letter if you had to write. For those that do it, or just summarizing documents, helping you write. I think there's a lot of opportunity there. Though I'd say the biggest change I've noticed in my job has been in the coding part of it.
Yeah, it helped me understand LaTeX, which is quite a bit of an accomplishment, I would say. So,
Yeah,
um,
and I think it's great at leveraging all this human information that's out there to help people understand something that someone else knows.
yeah, breaks down those barriers, right? Where LaTeX is usually the language of research, and
Yeah,
it's people
yeah,
in the industry rarely are familiar with it. But then I could basically use this to leverage some of that code. And I think what you shared around a lot of the polishing aspects are fair game for Gen AI, because
yeah,
then you control the content, but then you're
yeah,
basically just getting it to polish it. Yeah.
yeah. I think so too.
So just in terms of the field, what would you say are some of the challenges in this area?
In terms of doing our job, things are changing. When I joined like 7 years ago, I think just being good was important. Being able to build good systems, being able to code well and all very important. But over time, organizations have gotten larger, and what's now another skill you need to learn is how to use existing resources to move faster. You can't. No one's going to ask you to build a dashboard from scratch. You have to reuse existing code, existing dashboards, and the people that do that well, rather than reinventing the wheel, are the ones that are keeping up with the times. And that's a new skill. Uh, but in terms of the jobs and other things, I think there are still a lot of jobs, though I'd say there are a lot more new graduates in data science today, and it's a lot more competitive. But I think there's still a lot of opportunity for a lot of companies to hire data scientists because they're getting lots of data, and they're not, they don't, they need to have the people who can look at this in a professional way. But
That's actually a very interesting observation you made about reusing frameworks. I feel like that might be more broadly applicable just in the engineering sphere overall. I mean, we see this happening with like open source projects which are out there. Of course, as technology matures, you already have a lot of this built out and prone to reuse.
yes, yes, exactly. And I think like it's not like people don't want creativity. It's more you want a standardization that makes it easier to build
Yes.
on top of it. So reusing is almost always better than rewriting something.
Yeah, absolutely. I agree. So for anyone who's trying to make a decision, and this one's a famous one, right, in terms of should I do a PhD? Should I go join a big company or should I join a startup? Do you have any words of wisdom?
Yeah, yes, I do. So, as someone who actually went with what they liked, I've seen that path. And I'll say that it's not the first thing I would say is always be aware of what are your career options later so that what you're getting into. Like I think there are some fields where there's really no future. And it's not a bad thing to get into them, but do get in knowing that hey, you might need to find another plan once you're in it. So that's the first thing.
Yeah.
The second thing, I think a PhD, people that do a PhD should be the ones that really like it, because there are a lot of hard things in a PhD that unless you really like what you do, you won't feel it. You won't be able to push through the pain in some sense. It's not as well structured as
Yeah.
industry. It doesn't pay as much. So you really have to like what you do to sort of make up for all of that. And yeah, and I think if you're ever in doubt, I would say don't do a PhD. I also think a lot of the skills you learn in working in a company can help you with a PhD. I think we're not taught those things like say planning, say asking questions, say defining the skills. I think in a PhD, no one ever defined a skill that PhD students have. But companies
Right.
do it because they need to grade everyone, they need to help people get better, and people are interested in developing themselves. So they have a lot of these built out, I think. But all of those are really valuable, even a PhD. And bringing some structure, like my PhD was particularly unstructured. It just was how it was done. I think if I had better skills about asking questions, about holding people like my advisor accountable in terms of, hey, should I do this or this, asking questions, what happens if this doesn't work or so on. I think it would have been a smoother ride.
I love the way that overall in your career choices, you've balanced the passion aspect with some of the practical aspects. And thanks so much for the words of wisdom as well. And thank you
Oh,
so much
sure.
for doing this interview.
Yeah, thank you so much for having me, Ashwini. I really enjoy listening to your podcast. I'm happy to do my part, especially with some things that are not talked about as much, like decision science.
Thank you for listening. If you enjoyed this episode, please like and subscribe to our channel on YouTube or on any podcast platform. Follow us on LinkedIn at Through the Corporate Glass. You can leave us a comment on YouTube or send us feedback via our website, throughthecorporateglass.com. We would love to hear your feedback.